From adversarial agent safety to long-horizon real-world evaluation and exact theory for energy-based learning, today's episode brings together three fascinating frontiers in AI. We'll look at how reusable skills can hide attacks inside ordinary workflows, why frontier agents still struggle in realistic multi-tool environments, and what a solvable Boltzmann machine reveals about phase transitions, sampling, and generation. If you're curious about where AI systems fail, how they can be measured, and what theory says about learning dynamics, this conversation is for you. Let's explore the first paper, Skill Safety Bench Evaluating Agent Safety Under Skill-Facing Attack Surfaces. Skill Safety Bench introduces a runnable benchmark for agent safety under skill-facing attack surfaces, targeting a gap in prior evaluations that focus on direct prompt injection rather than adversarial local context surrounding reusable skills. The benchmark contains 155 adversarial cases built from 47 executable tasks, organized into 6 risk domains and 30 canonical categories. And each case is verified by a case-specific rule-based script that checks concrete run artifacts such as traces, leaked payloads, output files, or modified environment state. The key novelty is that the user request stays benign while the attack is embedded in skill guidance plus local artifacts like wrappers, Docker files, memory stores, retrieval corpora, and dependency files, making unsafe behavior emerge through ordinary agent workflows. Human review and LLM as judge validation with Kimi, K2, 5, and GLM 5. One report over 92% pass rates on camouflage and verifier alignment, with 94% plus per case agreement, supporting benchmark soundness. In experiments on Codex, Claude Code, Gemini CLI, and Kimi Code CLI across GPT-5, 5, GPT-5, 4, Opus, 4, 6, Sonnet, 4, 6, Gemini, 3, Flash, GLM 5, 1, Minimax, 2, 7, and Kimi, K2, 5. Overall attack success rate ranges from 15.5% to 50.3%. Codex with GLM 5, 1 is worst at 50.3%, while Claude Code with Opus 4.6 is lowest at 15.5%. Risk is highest in RD1, context trust attacks at 58.7% ASR, and lowest in RD3 execution. Runtime attacks at 19.2%, showing that agents are more vulnerable to poisoned workflow context and output externalization than to explicit runtime compromise. Let's explore the second paper, Spherical Boltzmann Machines, a Solvable Theory of Learning and Generation in Energy-Based Models. This paper introduces the Spherical Boltzmann Machine, an energy-based model on the n-sphere with quadratic energy, and solves its high-dimensional learning and generation behavior exactly in the large N limit. Using random matrix theory for the learned coupling spectrum and dynamical mean field theory for Langevin training with persistent Monte Carlo sampling, the authors derive closed-form equations for the Bayesian evidence, weight overlaps, and sample statistics, and identify cascades of phase transitions driven by alignment and condensation of the top eigenmodes of the coupling matrix to the data covariance. The theory predicts 4 concrete generative effects. Post-training sampling temperature tuning can improve sample quality by moving a model between silent and condensed phases. Reverse KL risk exhibits double descent as regularization gamma varies, with a sharp bump tied to a transition where a data-aligned outlier merges into the bulk. Posterior tempering produces warm or cold optimal temperatures. Eta is not equal to 1 depending on signal to noise, and finite sampling rate training can leave the model out of equilibrium, causing the learned weights to overshoot their stationary values and bias generation. The paper validates these mechanisms in standard architectures beyond the SBM, including Potts-Boltzmann machines trained on PFAM protein families, PF00072 and PF00018, a normalizing flow on the sphere, a Gaussian Bernoulli RBM on Kenneth French 49, industry returns, a Bayesian GAN, and Potts BMs on lattice protein sequences. Quantitatively, temperature tuning on PF00072 peaks near beta is approximately equal to 1.5. PF00018 near beta is approximately equal to 1.75, and the RBM test NLL shows A is approximately equal to 0.3 nats. Day double descent bump when a second singular mode collapses. Let's explore the third paper, Wildclaw Bench, a benchmark for real-world, long-horizon agent evaluation. While Claude Bench introduces a native runtime benchmark for long-horizon CLI agents that departs from synthetic sandboxes and final answer scoring by evaluating 60 human-authored bilingual tasks inside reproducible Docker containers with real tools such as shells, browsers, file systems, email, and calendar APIs. The suite spans 6 categories, including 26 multimodal tasks, and uses a hybrid grader that combines deterministic rule checks, environment state auditing, and GPT 5.4 or VLM judgments on semantic outputs. Across 19 frontier models, the best result is Claude Opus, 4.7 at 62.2% overall under OpenClaw. While every other model stays below 60%, scores range from 19.3% to 62.2%, showing substantial headroom. The benchmark also isolates system effects, changing only the harness shifts a model by up to 18 points, and multimodal workflows consistently trail pure text tasks for several models. For example, GPT 5.4 at 40.2% versus 58%, and Claude Opus 4.7 at 58.5% versus 65%. The paper further shows that adding domain skills can improve GPT 5.4 by 5.2 points overall and by 22.4 points on code intelligence, but can also hurt other categories, underscoring that agent performance depends jointly on model, toolset, time, budget, and control loop, rather than on base model capability alone. That's a wrap on today's AI paper highlights. Thanks for watching.